Here I will show you the operation of non-inverting zero crossing detector circuit. Output, this is output terminal, and output is not connected with the input in any of the input terminal, therefore this is a open loop operational amplifier. So its output voltage VO will be equal to A into VD. A could be 10 to the power 5 to 10 to the power 8. Okay, now see, we are applying the input voltage at the non-inverting terminal, therefore it is non-inverting zero crossing detector, because this inverting terminal is directly grounded, therefore its reference voltage is equal to 0, and here input voltage difference VD equal to input voltage minus reference voltage, and here reference is equal to 0, so VD equal to VI. When Vi greater than 0, that means input voltage is positive, our input voltage difference is equal to Vi, so it will be also positive, therefore our output voltage Vo AVD will also be equal to positive, and it will operate in the positive saturation region when Vi is less than 0. Input voltage negative, our Vd will be negative, so our Vo equal to AVD, and it will be in negative saturation region. So this is the principle of operation of zero crossing detector. When input voltage, as we are applying a sinusoidally varying quantity, when input voltage is greater than 0, that means it is in positive half cycle, then our output voltage will be in positive saturation voltage, and when input voltage is less than 0, then our output voltage, that means the input voltage is in negative half cycle, our output voltage in negative saturation region. Okay, this is the waveform. We are applying a sinusoidally varying input voltage, so this is our V in Vi, and this is our reference voltage equal to 0, that is indicated with this paste colored shaded region. When from this interval to this interval, the input voltage in positive half cycle, therefore our input voltage Vi greater than 0, so our output voltage will be in positive saturation region. See, from this interval to this interval, our output voltage will be in positive saturation region. When it crosses the 0 axis, when it crosses the reference voltage, that is from this interval to this interval, it is in negative half cycle, that means our input voltage is less than 0, then our output voltage will be in negative saturation region. So from this interval to this interval, our operational amplifier will be in negative saturation region, and the similar thing repeats for the upcoming half cycles. From this interval to this interval, our operational amplifier will be in positive saturation. From this interval to this interval, our operational amplifier will be in negative saturation if Vi is less than 0. Our output saturation voltage, positive saturation voltage, is controlled by positive supply voltage Vs, and negative saturation voltage is controlled by negative supply voltage minus Vs. Now let me show you the transfer characteristics of this circuit. In the x-axis we are taking input voltage, in the y-axis we are taking output voltage, and here we have reference voltage Vo equal to 0. The points in the right, the points in this region where Vi greater than 0. See, when input voltage is greater than 0, our output voltage will be in positive saturation region. So this is our positive saturation voltage, which will be nearly equal to our supply voltage Vs. When Vi less than 0, our output voltage will be in negative saturation voltage in this region. Okay, in this region our input voltage Vi is less than 0, therefore our output voltage will be in saturation, negative saturation, and our output voltage, negative saturation voltage, is controlled by the value of negative supply voltage. Okay, this is the transfer characteristics of non-inverting zero crossing detector. Okay, that's it. Thank you.